We proceed exercise 2.2 of polynomial. In the previous video, we have discussed till up to question number 2. Now we will discuss question number 3. In question 3, verify whether the following zeros of the polynomial. Verify whether the following are zeros of the polynomial. Verify whether the following are zeros of the polynomial. Whether the following are zeros of the polynomial. Whether the following are zeros of the polynomial indicated against them. Indicated against them. The first part is px equals to 3x plus 1. Px equals to 3x plus 1, and the value of x is given minus 1 by 3. The value of x is given minus 1 by 3. So we put the value of x equals to minus 1 by 3 in the expression, and if the result comes to be 0, then we say that x equals to minus 1 by 3 is the zeros of the polynomial. So we put the value of x equals to minus 1 by 3. So 3 into minus 1 by 3 plus 1, 3 and 3 gets cancelled, so it comes minus 1 plus 1 equals to 0. So the result comes to be 0. So we can say that x equals to minus 1 by 3 is the zeros of the polynomial. Minus 1 by 3 is the zeros of the polynomial. In the same way, let us see part 4th. Part 4th we have given px equals to x plus 1. Px equals to x plus 1 and x minus 2. Px equals to x plus 1, x minus 2, and the value of x is minus 1 and 2. The value of x is minus 1 and 2. So we put the value of x as minus 1. So minus 1 plus 1 and minus 1 minus 2. So minus 1 plus 1 0 into minus 1 minus 2 minus 3, which comes to be 0. So the result comes to be 0. So we will write that x equals to minus 1 is the zeros of the polynomial. Now we put x equals to 2. So we find P2, the value of x, we put 2. So it gives 2 plus 1 and 2 minus 2. 2 plus 1 and 2 minus 2. So 2 plus 1, 3 into 0. Again it comes 0. So we write that x equals to 2 is the zeros of the polynomial. X equals to 2 is the zeros of the polynomial. So both the terms x equals to minus 1 and x equals to 2 are the zeros of the given polynomial. Let us see part 7. In this we have given px equals to 3x square minus 1. Px equals to 3x square minus 1. And the value of x is given minus 1 by root 3. X equals to minus 1 by root 3 and 2 by root 3. So first we will put the value of x equals to minus 1 by root 3 in the given expression. So 3x square means 3 into minus 1 by root 3 the whole square. Minus 1 we get 3 into the minus the square, it becomes plus. And 1 by 3 minus 1, 3 and 3 cancelled, and the result comes to be 1 minus 1, 0. So x equals to 1 by root 3 is the zeros of the polynomial. 1 by root 3 is the zeros of the polynomial. In the same way, now we put the value of x equals to 2 by root 3 and we calculate p of 2 by root 3. So 3 into 2 by root 3 the whole square minus 1. So 3 into 4 by 3 minus 1 and it gives 3. So since the result doesn't comes to be 0, when we put the value of x equals to 2 by root 3, so we conclude that x equals to 2 by root 3 is not zeros of the polynomial. It is not the zeros of the polynomial. So this is the way to do such type of questions. Now we see question number 4. Question 4. Find the zeros of the polynomial. Fourth question. Find the zeros of the polynomial. And the first part is px equals to x plus 5. Px equals to x plus 5. So for finding the zeros of the polynomial, we make polynomial equals to 0. We make px equals to 0 for finding the zeros of the polynomial. We make it px equals to 0. This means x plus 5 equals to 0 and the value of x be calculated. So x equals to minus 5. So the zeros of the polynomial is x equals to minus of 5. The third part is px equals to 2x plus 5. So for finding the zeros of the polynomial, make px equals to 0. This means 2x plus 5 equals to 0 and 2x equals to minus 5 and the value of x comes to be minus 5 by 2. If part px equals to 3x, px equals to 3x and we have to find the zeros of the polynomial. So we make the px equals to 0. This means 3x equals to 0 and the value of x is 0 by 3. So x equals to 0 is the x equals to 0 is the zeros of the given polynomial. So the zeros of the polynomial in this case is 0. In this case the zeros of the polynomial is minus 5 and in this case the zeros of the polynomial minus 5 by 2. Because when we put the value of x equals to minus 5 in this expression, we get px equals to 0. When we put x equals to minus 5 by 2, we get the result as 0. Now the seventh part, px equals to cx plus 2. Px equals to cx plus 2. So again we make px equals to 0 and cx plus b equals to 0. Then cx equals to minus b and x equals to minus b by c. Let us see exercise 5.3. Exercise 5.3. The first question is find the remainder. When find the remainder, find the remainder. When find the remainder when x cube plus 3x square plus 3x plus 1. X cube plus 3x square plus 3x plus 1 is divisible by x plus 1. The first part is divisible by x plus 1. The first part is x plus 1. The second part is x minus 1 by 2. X minus 1 by 2. And the third part is x, then x plus 5. X, fourth part is x plus 5. And fifth part is 5 plus 2x. 5 plus 2x. So in each of the cases, we have to find the remainder, and the condition is that this expression, the polynomial, is divided by x plus 1, x minus 1 by 2, x plus 5, and 5 plus 2. So let us see the first part. We have to make it equals to 0. X plus 1 equals to 0. We have to make it equals to 0 and have to find the value of x. We get the value of x equals to minus 1. Now put the value of x equals to minus 1 in the given expression. So the expression is x cube plus 3x square plus 3x plus 1. This is px. Now put the value of x equals to minus 1. So p of minus 1. So minus 1 the whole cube plus 3 into minus 1 the whole square plus 3 into minus 1 plus 1. So minus 1 the whole cube minus 1. Minus 1 the whole square plus 1. Plus 1 multiplied by 3. 3 into minus 1. Minus 3 plus 1. So we get 0. So in the first case, the remainder comes to be 0. The remainder is 0 for x plus 1. When the given polynomial is divided by x plus 1, the remainder we get 0. There is another method also to find the remainder by division method. We divide the given expression by x plus 1. So here we will write x plus 1 and we have to divide the given polynomial x cube plus 3x square plus 3x plus 1. So to divide this, we have to observe the first term of both divisor and dividend. The first term of the dividend is x cube and the first term of divisor is x. So divide x divide x cube by x. X cube divided by x, we get x square. So here we will write x square. So x square multiplied by x, we get x cube. And x square multiplied by 1, we get x square. Then change the sign of the denominator. Plus minus gets cancelled. 3x square minus x square, 2x square, then plus 3x and then plus 1. Now the first term of dividend is 2x square and the first term of the division is x. So divide 2x square by x. We get 2x. It means we have to write here 2x. And 2x multiplied by x. We get 2x square and 2x multiplied by 1. There comes to be 2x. Change the sign. So plus 3x minus 2x. We get x and it remains 1. Then x plus 1 divided by x plus. It goes by 1. So x plus 1. Change the sign. So the remainder we get 0. So these are the two ways to find the remainder. For part second, solution of part second, x minus 1 by 2. X minus 1 by 2, make it equals to 0. So x minus 1 by 2 becomes 0 and find the value of x. So x comes to be 1 by 2. Now put the value of x equals to 1 by 2 in the given expression. So the expression we have polynomial x cube plus 3x square plus 3x and plus 1. Put the value of x equals to 1 by 2. So p 1 by 2 equals to 1 by 2 the whole cube plus 3 into 1 by 2 the whole square plus 3 into 1 by 2 plus 1. We get 1 by 8 plus 1 by 2 the whole square 1 by 4 multiplied by 3, 3 by 4 plus 3 by 2 plus 1 by 1. Now take the LCM. So LCM will be 8. We get 1 plus 6 plus 12 plus 8. And the result comes to be 12 plus 8, 26 plus 1, 27. 27 by 8. So this is the remainder. Now we do this question by another method by division method. So for this we have to divide this expression by x minus 1 by 2. So divisor is x minus 1 by 2 and the dividend is x cube plus 3x square plus 3x plus 1. So the first term of dividend is x cube and the first term of division is x. So x cube divided by x, it becomes x square. So here we write x square and we multiplied x square by both the terms and write down at this place. So x square into x cube plus minus minus x square multiplied by 1 by 2. It gets x square by 2. Change the sign of denominator. So x cube and x cube cancelled. From both the terms, x square is taken common. So we get 3 plus 1 by 2 and then plus 3x and plus 1. So we get 3 into 2, 6 plus 1, 7 by 2. 7 by 2x square plus 3x plus 1. Now the first term of the dividend is 7 by 2x square and the first term of divisor is x. So it comes 7 by 2x. Means here we have to write 7 by 2x. So 7 by 2x multiplied by x, we get 7 by 2x square plus minus 7 by 2 into 1 by 2, 7 by 4x. Change the sign, it gets cancelled. So we get, taking x as common, we get 3 plus 7 by 4 and plus 1. So when we solve by taking LCM, 4 into 3, 12 plus 7, 19. So x into 19 by 4 and plus 1. Now the first term of dividend is 19 by 4. 19 by 4x, and the first term of divisor is x, so x and x cancelled, it remains 19 by 4, so here we will write 19 by 4. So 19 by 4 multiplied by x means x into 19 by 4 and plus minus 19 by 8. 19 by 4 multiplied 1 by 2, 19 by 8, change the sign. So it comes 1 plus 19 by 8 and the LCM comes to be 8. So the result will be 8 plus 19, 27 by 8. So in this case the remainder comes to be 27 by 8. Now the third part, there is x, so we make it equals to 0, x equals to 0, and the polynomial is px equals to x cube plus 3x square plus 3x plus 1. Put the value of x equals to 0. So 0, 0, 0 and we get 1. So p of 0 equals to 1. So the remainder we get is 1. The remainder comes to be 1. Now by another method we have to divide. X is divisor and the dividend is x cube plus 3x square plus 3x plus 1. So the first term is x cube, this is x, which goes by x square into x cube, sign changed, then it comes 3x square, now it goes by plus of 3x multiplied by x, 3x square, change the sign, then comes 3x, then it goes by 3 multiplied by x, 3x, and then it remains 1. So the remainder comes to be 1 by division method. Now the fourth part of this question. Firstly, we have to make it equals to 0, x plus y equals to 0, and we find the value of x. So x equals to minus 5, and the polynomial px is x cube plus 3x square and plus 3x plus 1. Put the value of x equals to minus 5, so it comes minus 5 the whole cube plus 3 into minus 5 the whole square plus 3 into minus 5 plus 1, and we get minus 5 cube minus the square plus, so 3 pi square plus minus 3 pi and plus 1. So the remainder we get p of minus 1. This is the remainder. Now by division method, x plus y is the divisor and the dividend is x cube plus 3x square and plus 3x and then plus 1. So the first term of the dividend is x cube and the first term of the divisor is x. So x cube divided by x. we get x square, means we have to write x square. So x square multiplied by x cube, and x square multiplied by pi. So we get pi x square. Now change the sign, x cube and x cube gets cancelled, and from these two terms x square is common. So it gives 3 minus pi x square plus 3x plus 1. Now the first term is 3 minus pi into x square. The first term of divisor is x, it goes by x, so it remains 3 minus pi into x. So here we write 3 minus pi into x, so 3 minus pi into x multiplied by x. The result comes to be 3 minus pi into x square, then 3 minus pi x multiplied by pi. So we get plus pi into 3, 3 pi, and pi into minus pi square into x, and plus. Now change the sign, it gets cancelled from these two terms. X is common, so we get 3 minus of 3 pi and minus plus pi square into x plus. Now divide the first term by x, so 3 minus 3 pi plus pi square into x divided by x, so we get 3 minus 3 pi plus pi square. Here we will write 3 minus 3 pi and plus pi square. So this multiplied by x, it comes 3 minus 3 pi plus pi square into x, and plus this multiplied by pi. So we get 3 pi, pi into 3 pi minus 3 pi square, and plus pi cube. Now change the sign, this gets cancelled, and the result comes to be 1 minus 3 pi minus plus 3 pi square, and minus pi. So this is the remainder. 1 minus 3 pi plus 3 pi square minus pi. So the answer is same by both the methods.